Thank you for coming, everyone. So I'm going to be talking about automating change requests, validation using industry foundation classes and natural language processing. I'll give a brief outline, so I'll give a bit of background on me, the project, the rationale for it, the LWIN system, which was the sort of system that we're trying sort of experimenting with commercialization, with which we build this research. I'll look at the change requests and the NLP approach we have for processing them. Then I'll look at the validation methodology, and then finally I'll look at some of the future work. My background's in computer science, software engineering. This project was undertaken as part of a KTP associate, which is a knowledge transfer partnership. This is a system in the UK where the government sort of gives finance to universities and companies in order to try and build bridges between the universities and companies to try and disseminate some of the research knowledge into industry. And I work for a company called Applied Integration. They're one of the UK's leading system integrators. They work with Siemens, PLCs, that kinds of thing. They're a reasonably small company. They're about 20 to 30 people, but they have a big investment in research. They really see the benefit of research. And this project kind of came about from their work that they do in the MEP domain. So they were quite far down the chain, and they obviously they see the knock-on effects that changes can have. So if you make a design change, then it affects everyone right the way through the chain. So they don't have as much expertise in the construction domain, but that helps with T-Side and Nash, his department, who have a lot of expertise in this area. So that's kind of how the project came about. So the main rationale for this is there are a lot of errors in construction projects. There's estimates from anywhere between up to 80% of the cost of a project can be in changes, and a lot of these, it's believed, occur in the design change or with consultants. There's been a lot of work done on change detection, including the system that we were working on as part of this project. That leads into the research that we've been doing. So this is a bit of overview of the system. It was originally called the LWIN system. We have renamed it to Architrack at this point, and it's seen a UI redesign since the paper, so it will look a little bit different if anyone recognizes it. It's a web-based system, so we use Angular for the user interface, C#, ASP for the backend, and we use XBIM as our method of processing and reading the IFC files. Yeah, and its main feature so far is it generates reports based on IFC files. So if you upload some IFC files, you can generate a comparison between the IFC files, and it'll show you a list of the objects that have changed, the details, things like that. And you can see a little preview in the browser. So I'll show a quick demo in a second. The demo shows an overview of the main features of the application. It uses the built-in smart duplex model as kind of the test case, and you'll see that throughout some of the other demos later on in the presentation. It's developed to be kind of a pragmatic application. We don't want to force a methodology of working on any of the companies that might want to use our product. I think that partly comes from slight lack of domain knowledge on applied integrations on my part. We kind of just want people to integrate into the current workflows. We're not trying to force anything on anyone. And it's built using web standards, so we designing it to be pretty extensible. We have ways that we could bring this to mobile. We're using IFC files as the main source of input right now. I should clarify, I'm sure everyone knows, but IFC files, like the kind of standard interchange format for 3D building models. And we have plans to open the API for public use, so other developers can get a key and they can start building on our software. The current version of the UI is built all on top using our API, essentially. So the foundations are there. So this is captured within the browser. So this is the main interface of the application. So in this demo, I walk through, I create a new project, I upload some IFC files, and then I generate a comparison between them. This is me just uploading 2 different versions of the duplex. The first version is the standard version that anyone can download from Building Smart. The second version, I've made some change to. So in this case, I've moved some furniture around and deleted some furniture as well, I believe. So at this point, I've uploaded both IFC files. You can see a little preview in the browser. Now I'm going to generate a comparison between these files. So yeah, so you can't really see the differences at this stage, but they are both different, trust me. Yeah. So now I'll go through and I'll create a comparison using both versions of the IFC files. And this is the comparison. So you can see it generates a report, a list of the objects that have been added, deleted, and changed. You can view details of the objects, and then the buttons at the top give you a little preview of the changes. So you can see it's grayed out all the colors, and it's highlighted the specific objects that have changed. So it has different colors for additions, deletions, and changes. Now I believe, yep, you can click this to zoom in on specific objects within the model. So for the change validation, we sort of imagine this kind of scenario from talking to some of the companies that we have like relationships with. It was very common for them to have the architects design a version of the model. They'd then send it out to contractors who'd make some changes. It was very difficult for them to sort of keep track of all the changes to identify the changes that had been made. It's a very manual process. So this is the kind of scenario that we were envisioning. The designer makes the initial model. They'd sort of submit that to our system. They'd then submit a change request for any additions that need to be made or corrections. That would then be sent to a contractor. They would implement the changes. They would re-upload a new version of the model. And then this would then be automated. So our system would then use the change requests, the plain text that the architect sort of input, and then that would validate the changes that are being made by the contractor. And then this would come back to the architect to have the final approval on whether the changes should go through. Okay, so this is a screenshot in the top left from the old version of the UI. As I said, I've rebuilt the interface, so not everything's back in the current version of the system. But this was sort of the idea behind it. So you could create a new change request. It has a big text box where you can just enter the change request in plain text. You can then click the parse button, and then this will parse out the properties into the little boxes below. So this will detect the objects involved in the change request. So the focus for this change request was on objects and sort of moving them around, deleting them as sort of this test case. So you can see it will parse out the type, the key object involved, and then the locations of the object involved. The NLP sort of processing sequence is built on core NLP, and then a series of state machines built on top of core NLP. So this is quite an old information extraction technique, but it's really effective. So this comes from my background in using NLP to parse out objects and requests and requirements from clinical guidelines. So there's quite a lot of similarities between the two. So it uses a system, it's kind of like regular expressions, if anyone's familiar with that. So you would have like, if you wanted to parse like animals or something like that, you might have like cat and then like cat S for like plural. But this using advances in statistical processing like core NLP, we can raise the abstraction a little bit. So we're not working at the pure lexical level anymore, we're working at tokens. So you can see in this case, the first stage is to classify nouns as objects, and then we can apply successive stages onto that then use the parts for each, and they can use the custom tags that we apply. So you can see for the end location, we have a pattern that's similar to like to object, that's marked as an end location, and then we can identify the start location by using a pattern object to end location. So it's quite effective, relatively simple techniques, but quite effective. So this is the main overview of the validation process that we use. So it uses the set of changes that we generate from the core system. It sort of brings in a formalized version of the change request. So this has all the information we need in terms of the object name, the locations involved, that kind of thing. And we can simply just do a check with the comparison that we made earlier in the stage. So it's quite fast. It usually leaves much less objects to check than checking through the entire version of the model. So this is a video capture from the desktop debug interface, again, because I'm rebuilding the main interface right now. But this just shows some examples of passing out different types of change requests. Passing out, different types, different objects, different locations, that kind of thing. Okay, so this is another demo. So this uses the change requests that are mentioned here. These are some changes that were actually made to the duplex shown earlier in the process. So you can see in the files, it's actually using the same IFC files that we showed the comparison for earlier in the system. So this is moving the sofa from one room to another. This will validate the change request. I'll then make some changes to break it just to show that it is actually working. And then I have a change request to delete an object that's validated as well. And then just to show, again, that it is real, you can see the preview of the objects. That was the table that was deleted. Viewed through the web interface of the system. Yeah, this is the couch that was moved. So this is the methodology that we've outlined. So the previous sort of validation process, that works well for modifications and deletions. Additions, slightly more challenging. The way we approached this was in a very sort of text-to-scene approach, if anyone's familiar with that approach. So there's a problem that exists in that space called grounding. It's where you take basically objects and things mentioned in plain text. So if I say move the couch from the living room to the upstairs bedroom, it's the process of how you actually map those to concrete objects. It's very, very difficult. But this is sort of the process that we outlined that could be used, sort of validate change requests. So we take the object name that someone's entered in the change requests, and then we can have a set of synonyms, and then we can break. We basically convert the object in the change request into a bag of words that consists of the name that was entered, all the associated synonyms, and then we can associate that with the names in the IFC file. So a lot of the times the objects mentioned in an IFC file will contain some sort of English names, just sofa, like in this case. And then basically we can use that process to try and find the best match. So we use this process in my thesis to map actions extracted from clinical guidelines to planning operators for an AI planning domain. We use a similar sort of technique of converting them both to bag of words and then measuring the overlap to come up with a semantic relevance. So the future work for the system, we need to improve the NLP. So there isn't really, what we found, a formal outline change request process that anyone's using right now. So we kind of just want to get it into users' hands, generate some more data, and then we can generate a real evaluation of the NLP approach. We probably use something like F-measure, if anyone's familiar with that. It's quite a common way of measuring the overall accuracy in information extraction. We also want to improve just the overall recognition, the overall system. So we could potentially see this as a case where it doesn't just support change requests. You could essentially create a set of static rules, like every room has to have a door, and then our system can just apply that every time. Sort of like unit tests in software development. So when you're developing things in software, you have a set of tests that you essentially keep alongside the product the whole time, and you rerun them every time a change is made, just to validate that nothing's been broken. We think an approach like that might work quite well. And then, yeah, we want to just continue integrating this into the overall process. Thank you. Any questions?